So this is where your bucket and your thermometer are going to come into play. So with a heat exchanger, it's important to not only measure the temperature of the two inlet streams, but the temperature of the two outlet streams, as well as the flow rates of both streams. So what you're going to have is you're going to have a bucket, which you can take a stopwatch measurement of the time that it takes to fill up this 2 quarts, divide by the time, and get your flow rate in liters per second. Ideally, you want both your cold water and your hot water inlet to be at the same flow rate, so that heat exchange will be the same between both streams. And then it's just as simple as putting a thermometer in and measuring the outlet streams.
And before we get too far there, normally what a TA or a professor would do is turn on both sources and then use a bucket and a stopwatch to time the flow rates so that they're approximately the same. And so that's what we're going to do right now.
I want to turn that one down a little bit. That was good stuff. Another good tip to reduce pressure in the lines is make sure that with all of these connections, they are as circular as possible. You don't want any kinks, just like standard stuff when you're doing your garden hose. So if you want to come over here and check out the bucket. So what we mean by the analysis for the flow rate is someone with a stopwatch timer would begin time now. And you simply wait until it fills up to the 2-quart line that's on here. So that'd be now. Stop whatever that time is. You can use that to figure out what the flow rate is. And then of course do that with the other stream. You guys get the picture. So just from visual analysis, it looks like these are roughly the same. So for this demonstration, we're going to say that that's good enough. Put your thermometer in and you can measure your temperature of your outlet stream. And again, you have a second bucket right here doing the same thing. So eventually this is going to get to steady state. And when that happens, you're really going to be able to see the temperature difference between not only what's coming in, so this will get up to about 50 degrees Celsius with the Van Zoren tap water, while the cold water inlet will get down to about 12, 13, 14 degrees Celsius. What's that one at right now? About 20, is that what it says? So already you can see quite a difference in that heat differential. The cold water is coming in at about 20 degrees, coming out at about 30. If we were to measure the hot water, might not work because we don't have a nice bucket for it, but hot water is coming in at about 120, and by the time that this is done, 50 degrees Celsius. By the time this is done, it will be at about 35. So you can see that temperature loss is occurring. Flow rates are about the same. This is all the data that you need to collect to do our heat exchange lab. You can see all of the connections are pretty much leak-free. Both of the end caps, both of the outlets, both of the inlets, the connection to the sink, and the connection on the wall. Everything is pretty leak-free and seems to be working well. Anything to add, Scott? No? Right? Thanks for watching.